Our last to doodle for Math B in the winter 2023 is this angles one. So we talked about unwinding a circle and that all the way around was bigger than 3 but less than 4, and we named it pi. But what if we're thinking differently and we only go part way around a circle? We want to kind of measure how far we go. So somebody grab that little picture of an archer from above and aim the archer not at the red dot, but at the blue dot.
So are we moving the
Archer here.
oh. Oh, okay. I didn't know what that was.
It's the best I could find, a crossbow person. And you grab the archer and spin it. Ta-da! So we want to be able to aim things carefully so we can shoot our cannons and spaceships and whatever in the right directions. If we didn't have to aim carefully, we could just use a clock and say, hey, the archer is aiming kind of between 3 o'clock and 4 o'clock. But if we want to aim more carefully, we need more than that, so we know where to aim the archer. Everyone okay so far?
Yeah.
So how much of a turn do we do? So there's 3 languages about this: degrees and radians and gradians. And the GED, I'm pretty sure, only cares about degrees. I'm going to mention the others just so you can be snooty, well-informed citizens and impress your friends at dinner parties, but degrees is where we're at. And the ancient Babylonians invented degrees, and they wanted to pick some really big number with lots of factors. So they picked 360. And that way, almost no matter what you spun the archer, the number of degrees that you went is a whole number, because who likes fractions? So I'm going to take my archer. If I spun them all the way, that's 360. If I spin them halfway, what's half of 360? If you need to, do it on a calculator.
180.
180. So I can take my 180 and stick it down there. Okay, what if I took my archer and spun it only a quarter of the way around? So I started here and just went a quarter of the way around. Grab the answer from over here and pull it onto our circle. We can do it on the calculator too. Let's take the 360. Oops. And we're going a quarter of the way around, so we're looking for 90. Are these too small to grab? I know 2 of you are eating dinner. Yay. So you may have seen a protractor. Did anyone play with protractors in school?
Yes.
This one is too small, but if I make it bigger, then you can see that 0 is up here, 90 is here, 180 would be way down at the bottom. So maybe that helps with things. Yeah. Okay, what if I started back at beginning and only went 1/8 of the way around? So now I'm aiming right there. I'm going halfway to 90. So what's half of 90? Help you get it there. Oh, okay. What if I took my shape and made 6ths? Oh, that's a terrible slice. So I'm doing it wrong. I have to have that one up there. So imagine that I'm drawing my pie slices better. Does that look like equal pieces now? Somewhat.
Yeah.
Okay, so 45 was there. This is just a little bit more than 45, but not to 90. My artwork is bad. If my artwork was better, then it would make sense that 60 is right there. Okay, let me erase my bad pizza slices. So 360 is all the way around. Someone got that. And then 3/4 of the round. So 190, 290s. What is 3 times 90? That's our last one. Okay, everyone happy with degrees?
Yeah.
There's an online protractor. I'm going to put it in the chat so that you can all play with it yourself. Haley and Cody, who are eating dinner, try and also play with this if you can. Doesn't take that much clicking. But look, I can make angles. Woo. So our first task will be to just play around with it as it is. When you first load it, then you'll notice it says 1 and show all. So keep it that way and try and make some of those angles we just saw. How big is 45 and 60 and 90 and 180? $45. There it is. 60. I drew it better. Ta-da. 90 was straight up, and so on. Any questions as you play with it?
No.
I wish Zoom had some like family Brady Bunch mode where you could all see our screens at the same time and we could each see what we're doing. That would be cool. Okay, complementary. So I'm going to take this menu option and change it to complementary. Ah, what happened? Now I have two angles. And if I notice, I can't change the outside ones. They're always 90 degrees, but the inside one I can wiggle. What's going to be true about the two numbers that I see?
Does it always kind of add up to like 90?
They do. They always add up to 90. So that's just the definition of complementary. Complementary means I have two angles and they add up to 90. I've somehow taken a 90-degree angle and I'm cutting it in two for some unknown reason. What if we change it to supplementary?
It adds up to 180.
Yeah, now I've taken the 180-degree angle, the halfway around, and I've chopped it into two things. Your textbook will make puzzles out of this. Let's go back to complementary. It will say you have two angles and they're complementary, but now I'm going to use this one and say calculate and then pick a random one. Why doesn't it? Should hide it. It's not working for me. Calculate complement there. So it's supposed to do it if it's working right, that it gives you one, and then you have to do 90 minus 36 to find what B is. Or 90 minus 20 if it was that picture, or something like that. Does that make sense?
Yeah.
Together they add up to 90. So 90 minus the one they give you is the other one. And similarly for supplementary, then whatever number they gave you, oh, let's use 50. If the whole thing is 180 and this is 50 of it, then that means B must be 180 minus 50, so 130. So those aren't hard at all, especially with a calculator. That's a nice, almost freebie problem. 180 minus 50. So there we go. In general, what kinds of things do people do with angles? They can give you an angle that's drawn, and then you're supposed to measure it. And in real life, that usually happens with a protractor. And take the protractor, put it on top, and see what the angle is. By this thing, by the way, I can make a protractor appear if I ever want to. What else can we do with angles? Well, maybe instead of giving us the angle drawn out to start with, they just give us a number of degrees and we have to draw the angle. Again, a protractor is your friend. Or something like this. Can you draw a 45-degree angle? Sure, I can draw a 45-degree angle. Ta-da. The third thing is the game we just showed you with subtraction. They give you complementary or supplementary, and you do either 90 minus something or 180 minus something and get your answer. And then there's puzzles where we know about some angle, but not others. There's some kind of situation happening. So let's look at this puzzle. There's two angles we don't know. This little square symbol means 90 degrees. So first, how big is the red angle?
Is it 70?
This part is 70. It needs to go a little more. How much farther does it have to go? So the whole angle is 180, right? All the way up to the facing the other direction. That was 180. So if part of it was 70, then the rest has to be 110. And by the way, this little symbol up top means degrees. You probably know that from cooking. Somebody tells us that the sum of all the angles inside a five-sided 1, 2, 3, 4, 5 polygon is 540. So if the whole thing is 540, how much is left over on the blue angle? Well, we have to take away 100 and 110 and 90 and 120. Take away 100, take away 110, take away 90, take away 120, and what's left is another 120. That doesn't look right. 120 is bigger than 90. Did I get my silly fact wrong? Did I do some typo wrong?
Did you not add the 70?
The 70 is outside.
Okay.
100, 110, 90, 120. 1, 2, 3, 4. The 100 and the 110. I'm sorry, the 110 and the 90 add up to 200, 300, 420. And that's right. Maybe whoever drew this is just drawing it very badly. That would be a shame if I had to find more clip art. Oh, well, okay. So it must be actually that the shape is like this, so that this angle looks the same as the other one that's 120, and they just drew it badly and I trusted them. Oh well, such is life. Okay, and again, as I promised, there's other ways to measure angles that you don't care about, but because you're well-educated people, you will hear about them very briefly. Instead of putting an archer inside the circle and spinning them, we could imagine wrapping a tape measure around the outside of your circle. So imagine you have one of those carpentry tape measures and you just stretch it out and you say, I'm wondering how much tape measure it takes to go from here to there. Your answer isn't going to be 90 anymore. It's going to be something else. So we just did a thing about circle perimeter. Remember that perimeter around a circle was pi times the width of the circle. So if we have a circle whose half of the width, the radius, is 1, then the whole width is going to be 2. So the perimeter of this circle is going to be pi times 2, which is about 6.3. I should make rounding there. And you can test this. If you found a piece of pipe that was 2 inches wide, and you took a tape measure and wrapped it around, it would get to 6.3. If that was true, then if I went a quarter of the way around, I'm at about 1.8. So if I took my tape measure and actually wrapped it around a pipe that was 2-inch diameter, it would be about 1.8 inches at that point. Can you picture a tape measure that's 1.8 right now?
Yeah,
So people that do this kind of thing, working with pipes, they don't want to try and stare at the pipe longwise, like down the barrel of a gun, and try and think about angles with degrees. They want to just wrap their tape measure around the end. And if it says 1.8, then that's what they use as an angle. So that's how radians are defined. All the way around a circle is about 6.3. That's about how accurate tape measures are anyway. And all you do is for a pipe that's 2 inches wide, wrap the tape measure around and read off the tape measure in inches. And that's how much you aim your angle. So forget that. You don't need to know that for the GED, but later on in a math class, if you hear about radians, don't be afraid. It's just somebody wrapping their tape measure around a pipe. Even less important are gradients. The French wanted everything to be like tens or hundreds, like the metric system. So they said, let's make a right angle 100 of something instead of 90. And the rest of the world said, are you crazy? We like 90 degrees. This is friendly. So unless you are part of the French artillery division, you will never encounter gradients. Just totally forget about them.